Welcome to Seismic Data Processing course. So in today's lecture we'll understand the type of seismic wave. We have two types. One is called body wave and surface wave. The body waves, the wave that will travel through the earth interior, deeper, and surface wave, this wave are travel through or next to the ground surface. Body wave will be very fast and will be the first one we're recording in our seismogram, and the surface wave will be very slow, and this surface wave is associated with large amplitude, large ground motion. The surface wave, it will cause most of the damages in the case of the earthquake, because this surface wave is a trap between two layers, and this trap will cause most of the damage to the buildings. Two types of body waves: P wave and S wave, and also we have the surface wave. We have Low and Rayleigh. So the P wave, the particle move back and forth in the same direction as wave propagation. This compressional and dilations. Compressional, it will the rock particles will be compressed and then reduce in size, and then dilations, it will spread out back to its original. You can think about like if you have a spring slinky when you're being pushed and pulled. So this type is called longitudinal compressional, because the applied pressure on the rock particles, it will be compress these rock particles and make the rock reduce in size, and then it's back to original after this wave is removed, this energy is removed. So this P wave is the fastest seismic wave, is the fast from the speed from 5 to 8 km per second, and these speeds vary with rock type, temperature, and pressure. So the P wave can travel through solid, liquid, and also the gases in the case of atmosphere. Why importance? This first arrival on seismogram used to estimate the event original time and distance, because it's the first seismic wave arrival on our seismogram. It will help to indicate the original time and distance, and also carry information about compressibility and bulk modulus of rock. So you can see the direction of rock particles, it will be the same directions as the wave propagation. This is the direction of propagation, and the rock particles, when it's compressed and back to its original, it will be the same direction with the direction of propagation. S wave, it's also called a secondary or shear, is transverse or shear. Particles move perpendicular to propagation direction, side to side or up down. So this type is called the shear transverse wave. The speed slower than the P wave, typically from 3 to 4.5 km per second. Can travel only through solid, cannot travel through liquid. So if this wave is absent, that means there is a liquid, and it's also very useful to indicate the outer core, because the S wave cannot travel through the outer core. And this is in case of natural earthquake. In the nature earthquake, the release energy will be very high, but in our case for geophysics, we generate the source. It will reach at maximum from 10 to 15 kilometers. It cannot go deeper. But these, in the case of the natural earthquake, due to the plate tectonic, the release energy will be very high, so the seismic wave, the P and S wave, can travel through the earth interior deeper into the inner and outer core. Why this important? Their absence or attenuation, loss of energy, reveals liquid layers, earth outer core. The difference between the B wave and second wave time difference are used to locate earthquake. So this is very useful in the seismological study. They use the P and S wave difference time to use to locate the earthquake. But this is only in case of the natural earthquake due to the plate tectonic. the direction of the particle motion will be up and down, perpendicular to the direction of propagations. It will be up or down, perpendicular to the direction of propagation. So elastic parameter and velocity. The P wave velocity will depend on the K, the bulk modulus, and the shear modulus, divided by the density. Okay, while the S wave velocity depend on the shear modulus and divided by the P density. So that's why the P depends on the both compressibility and shear strength, while S depend only on shear strength. We have low waves, the surface wave. The ground move side to side horizontally along the surface. You can think about like a snake moving across the ground. There is no up and down motion, just side to side horizontally. So example, if you stand during the low wave, you will feel like a ground shaking left and right, not up and down. So low wave happen when the ground has two layers. Like we have a hard rock layer, and top of the hard rock layers we have the soft layers. For example, we have sand, salt, and clay next to the surface. So the difference between the soft and hard layer is called velocity contrast, because wave moves slower in soft material and faster in hard rock. So that's why this low wave is concentrated within the low sediment, because it cannot separate faster down deeper because this hard rock layer. So the wave, it will be slowly traveling within the upper sediment, the upper layer, and this is where the low layer is concentrated. So the speed usually slightly slower than Rayleigh waves, but faster than some other surface modes. Strongly dispersive, like different frequencies. Dispersive, that means the different in frequencies, low frequencies and high frequencies, because the layer contrast. The damage cause strong horizontal shaking side to side, very damaging to building. And this is how the low wave are motion. So direction will be side to side within the direct of the propagation. It will be side to side the motion. You can think about like snake moving to the ground, side to side. We have Rayleigh wave. The ground moves in a circular or oval elliptical shape. This motion happens in a vertical plane, so the ground moves up and down and back and forth at the same time. So this is not like side to side, it is up and down. For example, imagine a small object floating on water. As the wave passes, it moves in a circle up, forward, down, backward. That's how the ground moves in a Rayleigh wave. So the speed, Rayleigh wave is the slowest of all the main seismic wave, slower than the PN wave and also slower than the low wave. They are dispersive, meaning that different frequencies or period travel at different speed. As we said, longer wave, that means low frequencies go deeper and move faster, but slower wave, higher frequency, stay near the surface and move slower. This is just a few hundred of meters, they're not very long. And shorter waves, high frequencies, stay near the surface and move slower. So that's why you can feel the earthquake, because these are concentrated next to the surface and it will keep very long. It will be very slow. The rock particles moving will be very slow. That's why you will feel most of the earthquake for a long time. So damage, large vertical and horizontal displacement, also very damaging. This is how the like circular or elliptical moving of the Rayleigh waves. When seismic wave encounter changes in rock properties, velocity, density, part of the energy is reflected and part refracted. So we use this fundamental reflected B waves from subsurface layers, produce the seismic section used in image geology. So we use the reflection B wave to study the subsurface geological rock, to study the accumulation of hydrocarbons, faults, and etc. We have frequencies in attenuation and dispersion. So for the frequency content, the body wave, especially B, often have higher frequency content than the surface wave, often for near source recording. But this depends on the source and attenuation and the loss of energy. So the attenuation, the wave travel through the ground, it loses its energy. We have high frequency wave and low frequency wave. If it's high frequency wave, it will be very short, sharp vibration, and lose energy very fast. That's why the body wave have high frequency, because this wave it will move very fast. Low frequency wave, it will be very long, slow vibration, keeps their energy longer, so that can travel further. That's why the surface wave can still be felt many kilometers away. So dispersion, surface wave move through layers of rock and soil that have different speed. Because the speed contrast, and this speed contrast will keep this surface layer concentrated on the upper part, on the upper part of the first layer. Because of this, each frequencies either is fast or slow vibration travel at slightly different speed. This effect is called dispersion. So geophysicists use to study near surface layers like soil thickness and rock type. Okay, so use of seismic wave, it's used in understanding the earth interior, global seismology. This in case of the natural earthquake like plate tectonic and oil and gas exploration, earthquake engineering and hazard assessment, civil and environment engineering, volcanic and earthquake monitoring, environmental and ocean studies, also for academic and research application. So this is all you need to know about the seismic wave. So thank you for watching and see you in the next video.